So I've compiled some questions on practice for Pythagorean identity. So I will use these three examples to explain them. Joey, could you please focus on this board? And this will be the last for today.
Oh, you might want to be quick because it's running out of battery.
Oh no. Can you do 5 minutes or 10?
I'm not sure there's probably.
Okay, if it stops, can somebody please take note? If you notice the camera stop, please call my attention to it and quickly get the second battery.
It'll make a sound.
You make a sound, okay.
Yes.
Please, someone please keep your mind on that. All right, everyone, before the battery, everyone please look up because we are running out of battery. So I have a 2-page worksheet here to practice something we talked about the last time. We talked about this last Wednesday, so that's why I'm quoting the date. Okay? But this is all you need to remember, and you don't have to memorize, it's in your formula booklet. This is just how it is used. We have another application later. Okay, maybe tomorrow we'll talk about that. But first of all, you want to find the exact value of values of sine theta, given that cos theta is equal to this. So all you have to remember is the identity. Okay? If you quote the identity, you say from sine squared theta, you can start with cosine if you want. Cos squared theta is equal to 1, you substitute. Sine squared theta plus 2 over 3 squared is equal to 1. Can you see that? Mm-hmm. So that your sine squared theta plus 4 over 9 is equal to 1. Then I can find sine squared theta as 1 minus 4 over 9. Yes? Yes. Which means my sine squared theta is equal to 5 over 9. Understand? Yes. Then my sine theta will be what? Square root of 5 over 9, but plus or minus. Say exact value of value, so there might be 2 of them. So you stop by saying sine theta is equal to plus or minus the square root of 5 over 3. That's it. Similarly, but this has extra condition. The extra condition is telling you where theta is, which quadrant. Which quadrant is this? Q1, 2, 3, or 4? 3. Between 180 and 270. Okay? So you have at the back of your mind, all students take coffee or chocolate. Okay? So your angle is here. Where your sine and cos are, then this is wrong. So I should change this to minus 1 over 2. Okay? So similarly, the only difference is when we get here, we have a reason to disregard one of them. That's the only difference. Yep. Okay? So again, cos squared theta plus sine squared theta are linear and in focus, no distraction. Cos squared theta plus minus 1 over 2 squared. Yes? Yep. So cos squared theta, this is positive 1 over 4. Yes? Yep. So cos squared theta, 1 minus 1 over 4. Yep. 3 over 4. So cos squared theta is 3 over 4. Which means cos theta is plus or minus square root of 3 over 2. Yes? Yes? Quickly.
But don't we just know this by looking at this thing, at the circle?
That's because this is 1 over 2.
Oh, okay. So,
I'm telling you how to solve in general when you have a case like this. So, from here, you say, but pi is less than that, which implies that your cos is less than 0. Or your cos is negative. You understand what I mean? Yeah. Therefore, our cos theta is equal to what? Negative. So instead of having plus or minus, you give a reason why one of them is not valid, and you now conclude. But you can see I worked with plus or minus until I stated the reason and concluded. Understand? Last but not the least, of course you will practice this, maybe at home, maybe when you come to class first, 20 minutes tomorrow, but at least I want it done today so that you do your practice with your partner. Last but not the least, we want to find sine and cos given tan. There is no identity connecting sine square and cos square with tan square. But we have an identity for sine and cos with tan, right? What is that identity? Sine theta. So from sine theta divided by cos theta equals tan theta. It means that sine theta divided by cos theta is equal to minus 12 over 5. Yes?
Yep.
Which means my 5 sine theta is equal to minus 12 cos theta. Yes?
Yep.
You just need to make one of them the subject, depending on the situation. If this was minus 12, this would have been minus 12. And this would have been sine is equal to this. Then sine is already made the subject.
Yeah.
Okay? And then you can use it. But here now, sine is not made the subject. So you can make sine or cos the subject, doesn't matter. But I'm just going to make sine the subject. So I get minus 12 cos theta divided by 5. Also, we know that sine squared plus cos squared is equal to what? 1. You have your sine, minus 12 cos theta over 5. You have another cos squared. The idea is to have one variable now.
Oh. Oh, yeah.
The idea is to have one variable.
Yes.
So you get 144 over 25 with cos squared. You have another 1 cos squared is equal to 1. This is 144 plus 1. Do you agree?
Yes.
That would be what? 169?
Yes.
169 over 25 cos squared theta. Yes?
Yes.
Yep.
Yes.
Such that your cos squared theta, do you agree when I say 25 over 169?
Yes.
Yep.
Yes.
Okay?
Yep.
Then cos theta will become plus or minus
Minus 25 over 13.
5 over 13.
Yeah.
Do we have any range of interval?
Yes.
Yes, we do.
Yes.
Which in quadrant is this?
4.
4. In the first quadrant, only cosine is positive.
Yes.
So which means you pick the positive one.
Yeah.
Okay? Since 3 pi, yes? Is it 3 pi over 2?
Yes.
Yeah, 3 pi over 2 less than theta less than 2 pi. It implies that cos theta is equal to negative 5 over 12. Over 13.
Huh? But isn't cos positive?
Oh, I'm sorry. 5 over 13. Okay? I don't have enough space to say cosine is positive. It's greater than 0. Understand?
Yep.
So this is what I'm picking, which is one of the questions.
Sine.
Then you come back to here and get your sign.
Yeah.
Okay? Therefore, sine theta is now minus 12 over 5. You can write cos theta first, so we know what you have done. Minus 12 over 5 times
5 over 13.
5 over 13, and that is minus 12. And you can see that sign is negative,
Yeah.
which is expected here.
Yes.
Any questions? That's all. Okay? So this is how we apply the Pythagorean identity that we did the last time. If you have time, you can do some in class. If you have time, do it at home. Otherwise, bring this paper back to class tomorrow. Yes, I'm going to take one picture too.
Okay, can I shut this?
Yes, you can turn that